In regular polygons, all the sides and all the angles are congruent. So this also works for equal angular, but we usually just use it with regular polygons. We can use this knowledge to find out all the angles because they're all the same. So in something like a square, I know that the sum of the interior angles is 180 times 4 minus 2, or if you haven't picked it up by now, this is one you'll probably memorize, 360. Since I know all those angles out of the 360, I just need to divide it by the number of sides that there are, 4. And then I figure out that each angle is worth 90 degrees. So we can kind of extend the formula a little bit for regular polygons. Each angle is equal to 180 minus 4, 180 n minus 2 divided by the number of sides n. So we can use that little formula there to shortcut it to get to a specific angle. All right. Example 2. Interior angle measure of a regular polygon. The poles for a tent form the vertices of a regular hexagon. So there it's telling me not only that it's regular, but how many sides it has, because a hexagon has 6 sides, right? And they're all the angles and all the measures are the same. When the poles are properly positioned, what is the measure of the angle formed at the corner of a tent? So they're asking for what is one single angle. Well, this is where our formula comes in. 180 times 4, not 4, because we're working with a hexagon, so there are 6 sides, minus 2, divided by the number of sides, 6. 180 times 4 is 720. Divide that by 6, and we get 120 degrees. So we'd say this angle in here is 120 degrees because all of the angles are 120 degrees, and that is our answer. Since that one went kind of fast, let's go ahead and think about this another way. We could do that same process but in reverse. If I know what the angle is on the inside, I can figure out how many sides it's going to be. So I could have a little formula: interior angle equals 180 minus times n minus 2 over n. If I know what this interior angle is, I can now solve for n because it's the only variable that's left. That's what we're going to do in this next example here. It's actually example 3. So we're going to find the number of sides given interior angle measure. The measures of an interior angle of a regular polygon is 135. So 135 is equal to 180 n minus 2 over n. And that's my setup. Now I just go to solve the equation, multiply both sides by n. That's always going to be your first step. And I'm also going to distribute here. Now you might worry for a second because when I'm solving for n, I'm going to subtract 180 n from both sides, and I'm going to end up with a negative number of n's. It's going to be minus 45 n. Now that's okay because we're going to divide that into negative 360. So we're divided by negative 45, divide by negative 45, and of course a negative by a negative is positive, so 360 divided by 45 is 8. So the measure of the interior angle of a regular polygon is 135. That means it had to be an octagon. The number of sides is 8, and if you want to be fancy, you can just give it its name, octagon.